Welcome to week 32 of Algebra 1. Okay, so technically, this is the last week of class. Okay, but I don't know if you notice. Let me share the screen here. Okay. I have actually a week 33 in the course, okay, because the Khan Academy course has another unit talking about irrational numbers and figuring out that. And so I have there another class on May 12th. All right. So technically we have one more class. Okay. Would that be all right? If we meet one more day. Okay. So Samuel.
I will be able to do the homework, but I won't be able to be in the actual live class.
Okay, that's totally fine, and if you want, you can watch the recording afterwards, okay, or however you want to do it, okay. But um, I got the assignments from Caleb Manuel, okay, super good, really nice notes. Okay, I really like this graph that you did, Caleb, relating the different forms of the quadratic equations. Okay, the vertex form, the standard form, the factor form, and then analyzing really how each one works differently and how they help us in different things. So really, that is very helpful. Okay, Vincent, great job also with your notes. I got here the notes of week 31. Okay, and very complete. Good. And you asked for help on the completing the square. Okay. So we'll get into that because last week we didn't talk much about that. And so that is going to help us see also the different forms of the quadratic equations. And Caleb, oh, Caleb Gallagher, also that is coming in here. Great work on also his notes. Very neat and readable notes. So super clear. I love how you put, the titles for each one of the videos and exercises and everything. Excellent work on these notes. Okay. And then here the transformation of the parabolas and so on. So great work, guys. Hello, SP. Hello, Caleb. Good to see you. And I was mentioning just a minute ago that we have a week 33. Okay. So we have another live class on May 12th. All right. So next week we have another class and we have the material to complete the course. Let me show you what we have left and open that up, make sure that we have that open. So we have week 33 open, talking about irrational numbers and the operations that we can do about irrational numbers. This lesson is really fascinating, the proof concerning irrational numbers. And then at the end, we have here the Algebra 1 course challenge. So this is basically an exam, okay? I think that is 30 questions going over all the different topics of Algebra 1, okay? And that is going to help you see and evaluate how you are doing in your math journey, all right? And then I have here a brief survey for finishing the course. Okay, so very important. Okay, give me feedback to me as a teacher and then about the course in general. any suggestions and ideas of what we can improve and do better. I'm always looking for feedback. And I'm really looking not only for positive feedback. If you have something that didn't work for you in the course, okay, let me know. All right, I really want to know that. Now, also for next year, okay, what do we do next year? And for next year in math, particularly, we have three courses that we are going to do. We are going to revamp all the math curriculum, okay? But it's going to take us time to do that. And so I'm going to make a arithmetic course, okay, for the beginners, getting into the online learning. This is going to be a very basic course in arithmetic, multiplication, addition, subtraction, all the different things to really help the students get into algebra. We are going to do fractions and things like that. Then Kristen Wilkinson is going to redo the new version of the pre-algebra course, and I have the geometry course. Okay, so we are going to be building this way. The following year, hopefully, then we will be able to redevelop Algebra 1 and Algebra 1. So we are going to divide this course that you just took into pretty much like two courses, okay, to go a little slower. Because, here at the end, this has been kind of marathonic, really, and so we want to spend a lot more time on linear equations and then also a lot more time on quadratics. And but to do that, we are going to split the course in two halves. Okay. And then after that, we will develop an algebra 2 getting into pre-calculus and then derivatives and integrals, which is calculus. All right. So if you haven't taken the geometry course, okay, I encourage you to take this one. This one is a fascinating course, really, really good. And after taking the algebra class, you will benefit a ton from taking this geometry course. Okay. How many of you have already taken geometry with me? Okay, so the Spurlocks, Mason and Samuel. Okay, Brigham and Kyron. Okay, Kyron, you also did geometry. Okay, he's like, kind of. All right. So, anybody else? I think that is about it. All right. So, Jace, did you do also geometry? Yeah, that's right. Yes. Okay. So that is kind of what we have in the plan for this next year. I wish that we had the next course ready for you, but at this point we don't have it. Okay. So one thing so I invite all of you to take this geometry course if you haven't taken it. If you have already taken the geometry course and you want to take it again, okay, Brigham, Samuel, Mason, Kyron, and Jace, if you want to take it again, that is kind of what I recommend, right? Because the Euclid is so awesome and fascinating, really. For those, four of you that you have already taken the course, okay, I can give you a free registration to retake the course if you want to do that. Okay, does that make sense? So I'm not going to expect you to pay again the tuition for a course that you have taken. All right. Okay. But just let me know, and then I can add you to the course that way. Okay. So, um, as you can see, my main interest is in your progress and learning. Okay. Hey, I'm not a very good businessman. you know. But I really want you to learn. That is all that I care about. Okay. Um, I have read Euclid many times. I have taught this course many years, and all the time I'm constantly learning and discovering new things and new ways of applying and understanding this. All right. So does that make sense, guys? For those of you who haven't taken the geometry course, that would be the perfect next step for you to do. Okay. So that is what I highly recommend. Sounds good? All right. Well, let's go into the completing of the square here. Okay. And so let's see. I have some notes here. And let me see what would be the best way to do this. Not this one. This. So let's give this a try. Let's see. Come on. Okay, let me share the screen with you. All right. So we have seen we have seen several forms, okay, of quadratic equations and different ways of tackling this. Okay. One of the general form, okay, is to do, let's see, go over here. So we do y equals ax squared plus bx plus c. Okay? All right, so that is kind of the general form of a quadratic equation, the standard form. A, B, and C are numbers, are coefficients. Okay. The square term, we have three terms, so this is technically a trinomial, so we have one term, another term, and another term here. And this is called the quadratic term, okay, because this one has x squared, so this is the quadratic term. What is the name of this term? What would we call this term? Sorry, I have a little frog on my throat here. Remember that we had also seen for linear equations, we have y equals mx plus b, okay? And we call this one the linear term, okay? Because it describes a line, And so even in a quadratic equation, we have the quadratic term, the linear term, and then c is just the constant, okay? The constant, or we know that this one is the y-intercept, okay? The y-intercept, because why is the c the y-intercept? In a linear equation, we have that this one is the y-intercept, okay? All right, or the constant term. Why is it that in both we have that the term that has no x is the y-intercept? Caleb?
Because if you look on a graph, like the cross, to find the y-intercept, you have to set x to 0. So then if you solve it, it's going to be A times 0 squared, which is 0, B times 0, which is 0, and you're just going to be left with C, which is the y-intercept.
That's right, yeah. So if we are going to look for x equals 0, you explain it really well. In all these cases, in both cases, if x equals 0, then these two terms disappear and I have y equals z. And in the linear case, we have that the mx term also disappears. The linear term disappears and I have c. So wherever c is, okay, that is going to be my intercept there. Okay, for the quadratic, we call it c. For the linear equation, we call it b. Okay. Potatoes, tomatoes, tomatoes. Okay, I don't know how do we say that. Okay. But you see, it's the same thing. Yeah? Okay. All right. What else do we know about this? What else have we seen about the features of the quadratic equation? So we know now that that c is going to be the intercept. What else can we know by looking at this, the quadratic equation and the coefficients? What else can we tell? How about what does A tell us? What does the coefficient A is going to tell us? I really have a frog in my throat here. What was the A coefficient good for? There is something that is kind of really obvious and cool about the A coefficient. What was it? What was the A coefficient good for? Has to do with frowny faces and smiley faces. Okay. Tell me, Caleb, what was it?
So if A is positive, then the parabola is going to be concave upwards. And if it's negative, then the parabola is going to be concave downwards.
Yeah, okay. Yeah. So A is immediately a giveaway for the shape, okay, of the parabola, how it's going to go up or down. Okay. And so in many cases, we've seen that the equation is x squared plus, let's see, 2x plus 4, okay, whatever. So what is A in this case? What is the value of A in this case? Okay, you can talk, guys. Okay, someone can really unmute.
One.
Yeah, it's 1. Okay, so you see, it's there. We don't see it, but we can assume that it's 1 and it's positive 1. So we have a smiley parabola there. If I have a negative, then it's minus 1 x squared. And so I have a frowny parabola. I have to tell you, in practical applications, in physics and engineering, in economics and everything, most of the times we are dealing with the frowny parabolas. Okay. See, most of the times we are dealing with the negative quadratic term there. So that is the very common case. Okay. So now we have, that is the standard form. Okay. Let's take a look at another case where I have, so if I have here y equals x squared plus, let's say, 3x. Okay. So, that is it seems that is kind of incomplete. Basically, what we are having here is that the constant term is 0. All right. So what do we know about this parabola here? If we just have that, what do we know about this parabola?
It doesn't have a y-intercept.
Well, it has a y-intercept, but where is it going to be?
At 0.
At 0, it was going to be at 0, 0, right there. Okay. Mm-hmm. Okay. So we know that from that one. Okay. So here we have now a binomial. You see that we have just two terms. Okay, we have two terms. Can I change this into a perfect square trinomial? All right, that is kind of the tricky thing, and the idea about this strategy of completing the square. Okay, so the whole strategy of completing the square is transforming a binomial, a quadratic binomial, into a perfect square trinomial. Okay, so the perfect square, okay, is going to be something of the shape of this and another number, okay, so let's say h, okay, to the square, okay. This is that, and it's going to then convert into x squared plus 2hx, okay, plus h squared. All right. So this is the perfect square trinomial. You have the three terms, and here we have the factor form of that, because this is x plus h times x plus h, okay, square. So far, so good. Are we okay? So that is kind of what we are trying to do. Let's convert the binomial into this other shape, okay? And so let's see how we go about it with this. Let me see. So when we look into this, if I consider that this number 3, okay, that this number 3 is the 2h, okay, all right, then I'm going to have to think of, and then I'm going to have that this other term here that I'm not seeing in order to convert it. Let's see, this one is going to be, if I see that the 3 is 2 something, then this is going to be 2, and then 3 divided by 2. Can you see that I'm not changing anything there? Okay. I'm multiplying by 2 and dividing by 2. All right. So, and that is that. So 3x is the same as saying 2 times 1.5x, or 3/2 x. That is exactly the same. Okay. And then I'm going to have that in order to complete the trinomial, I'm going to have to square this term. Okay, so if the h is 3/2, okay, then the trinomial here is going to be 3/2 square. Okay. So far, so good? Okay, all right. So let's see if we can do that. All right. So Now, if we have the let me rewrite the equation with the transformation. So if we have that, we have 2 3/2 x plus 3.5 squared. That would be 9/4. Okay. All right. Now, the thing is that in order to do that, I had to also add, usually we have this equals 0, but I had to add 9/4 to both sides. Okay, so I have here the 9/4 also in order to maintain the equation, to balance things. Yeah. This term didn't change. The second term didn't change at all. I just transformed the 3 into 2 3/2. Okay. But here I added 9/4, so I need to add 9/4 to the other side to maintain the equation and balancing things. Okay. So now we have that 9/4, okay, 9/4 equals these three terms that now we have a perfect square here. Now we have a perfect square trinomial. Okay. These are square numbers. This is a square term. So this side, the right side of the equation, is going to be x plus 3/2 square. Okay. Question, Brigham?
So, but what about the y? Does that just not just go away?
So the you can have the y there, okay? So but in this case we are basically trying, always with these quadratics, we are trying to see when y equals 0, okay?
We
To
didn't.
find the roots of the parabola. Okay, so we want to find the root of the parabola, and so we equate y to 0. So this would be 0 plus 9/4. Okay.
So you just basically putting y at 0.
Exactly. Yeah, we put y at 0. Okay, and so we just have it that way. Okay. So the purpose of factoring, remember I mentioned this several times, that the purpose of factoring is to find what are the roots of the parabola. The roots of the parabola are the spots where the parabola crosses the axis. Okay. Yeah. So, if we have the parabola this way, okay, a smiley face and so on, we know that is going to be the parabola there. Okay. So now this equation now is, we have basically done the technique of completing the square and factoring the binomial into a perfect square form. Okay. And this is also called the vertex form of the parabola. If you want y again, okay, so if we have y here, we can have, let me do it here let's continue with that. If we have y there, we can say this is y plus that, okay, and y plus that. All right. And so I can move now this term, okay, this term here to the other side of the equation. And what would I have? I have y equals x plus 3/2 square minus 9/4. Yeah. Okay. You see that it goes from positive, of course, to negative now, this term. And this is the vertex form of the equation. Okay, so that is vertex form of the equation. The vertex form of the equation is useful because it helps us to see where the vertex is in the parabola. Okay, so it's helping us to find this point there. Okay, and so we have that the constant term, and so now we have a constant term, this one here. Okay, so this is still the constant term in this case is minus 9/4. All right, and so if I'm going to let me go over here now. Let's draw this parabola. Okay, so where is the parabola going to intercept? Where is the parabola going to intercept the y-axis? Okay, so where is the y-intercept in here? Where is it going to do the intercept? Let's see, if x is 0, okay, so if x is 0, we are going to have, okay, that is 0, so it's going to be plus 3/2 square, okay, so that is going to be 9/4, okay, minus 9/4, all right, so I end up that is going to be 0, 0, okay, yeah, so the intercept is going to be over here, okay, all right. Let's see from here, from this equation here, how do I find the roots? Okay, so how do I find the roots of this? Okay, so if I go, the vertex form is useful because then it's going to tell me that this term is going to shift, okay, the equation up or down by that much, okay, and this one is going to shift it left or right. That is kind of the idea of this, and so we are going to see how that goes in here. Let's do now that. Let's say where y equals 0 and solve for x. Okay, let's take a look at that and see what we have here. So when y equals 0, we have x plus 3/2 square minus 9/4. Okay, so we can, of course, move back the 9/4 over to the other side. 9/4 equals x plus 3/2 square. Okay, all right. And now let's keep solving for x. So if we distribute that, we are going to end up with 9/4. Okay, and we go back to the standard form of this. So it's going to be 3x plus 9/4. All right. And then we go, this term is going to cancel with that. So we are going to end up here with 0. That is where we started. Okay. And let's see, x0, 3x. Okay. And we go, let's see. Oh, okay. So the root is going to be right here for this parabola. Sorry, this color there. So it's going to be 0, 0. So the parabola is positive. So the parabola is going to be going this way over there. Okay. So these are different ways of manipulating the different equations. Let's do some exercises with this and see how it goes. Okay. So let's see. And I'm going to go to GeoGebra here. Okay, let's see if we go here to the graphing calculator. And I'm going to enter an equation, y equals x plus 3 square, okay, minus 4. Okay. All right. Okay. And so here we have that. This is in vertex form. Okay. This is in vertex form. This equation there is in vertex form. And it's telling me, let's see if I annotate here. Okay. The minus 4 is the y value there of the vertex. Okay. And then this coefficient, but minus this coefficient, minus b, is going to be where the x value is for that. Okay. All right. So I think that I was wrong on this other case here. Let me do that. Right. So clear the drawings and let's go over here. And so in this case, okay, where we have, in this case over here, okay, in this case over here, we have that minus 9/4 is going to be over, around this spot. So if we have, so it would be like minus 2 1/4, okay. So minus 9/4, all right. And then minus 3/2, okay, about here is going to be the vertex of the parabola. Okay, and I know that the parabola is going to be upwards, and so it's going to be kind of like this, there, that way. So the vertex form tells me where the vertex is in there. Okay, that is the idea about that one and why we wanted to find that other form of the equation. Okay, so let's see. Let me go over here and let's do some exercises here. So let's see. I have some cases. Okay. All right, so let's take this, and I want you to solve this and graph it. Okay, so what we want is to change this formula into the different forms and see how it works. So we have y equals x squared minus 4x plus 3. Okay, so the assignment is change this equation to the vertex form of the equation. You can factor it. Okay, so this is the standard form. Okay, we have the standard form, the factor form, and then the vertex form. So let's see if we can take a look at that and see what we have. How we can change this from one to the other. And also, I want you to tell me this one. Okay, is it this equation, is it frowny or smiley? Okay. How many intercepts? Okay. How many intercepts? The number of intercepts. Okay. All right. And where is the axis of symmetry? Basically, the axis of symmetry is going to be where the vertex is on the x-axis, axis of symmetry. Okay. Can we find that from this? Right. Let's take a look at that and see what we have. Remember that one thing that you can always do, that is kind of the shotgun approach to solving all of this, is always to use the quadratic formula, okay, for finding the roots, So x, okay, the finding the roots. How is the quadratic formula go? I told you to memorize that one.
X equals negative b squared.
Negative b.
No, not negative. Wait, yeah, negative b squared. And then
Negative b, not yet, not the square yet. Okay. Plus or minus
square root of b squared
Yeah.
minus minus 4 AC over 2A.
Okay. All right. So this is something super interesting here. Okay. So what do you have, Vincent? What have you found out? What do we have yet?
I think, is there two intercepts on the 1 and 3.
Uh-huh. Okay, so that is great. So let's solve for this. So if we apply, what did you do to solve it? Mm-hmm.
I plugged it into the formula, the quadratic formula.
The quadratic formula. Okay, so if we have that, then we are going to have x equals minus b
It
is
was
4.
positive. Yeah, positive.
Okay, plus minus, okay, minus 4 square. I'm going to write it down. Okay, plus, okay, sorry, minus 4 minus 4, and then a is 1 times 1 times c is 3. Yeah?
Yeah.
Okay. And then all of this divided 2 times 1.
Mm-hmm.
Okay. All right. So let's continue solving this. So we have 4 plus or minus, and then the square root of, let's see, minus 4 square,
16.
16, minus
12.
4 times 1 times 3, minus 12. Yeah.
Mm-hmm. Yeah.
Mm-hmm.
Over 2.
Okay. Divided 2. All right. So that would be 4 plus or minus 16 minus 12 is 4. The square root of 4
2.
is 2.
2.
Yeah.
And then all of that divided by 2. And then 4 plus 4 is 6 divided by 2 is 3. And 4 minus 2 is 2 divided by 2 is 1.
Okay. So those are my roots. Yeah.
Yeah. That's what I
Okay.
got.
So 3 and 1. So let's see. Is the parabola frowny or
It's up.
smiley?
Smiley.
It's a smiley. How do you know that it's a smiley?
Because A is positive.
Yeah. A equals 1. Okay. Positive. All right. So we can write it more technically. Okay. So that A is greater than 0. Okay. Yeah. So the numbers of intercepts, okay, we have that is 3 and 1. Okay. The interesting thing is that this part of the quadratic formula, okay, what is underneath the square root is called the discriminant, okay? This is what is going to tell us if we have two roots, two real roots, two imaginary roots, or one root, okay, in the parabola. Because look at this. If I have that b squared minus 4ac, there's three cases. Okay, it could be that all of this is greater than 0. Okay, it could be that b squared minus 4ac equals 0, or it could be that it's less than 0, it's negative. Okay, yeah. So if I have a positive number of all this, if this ends up being positive, being greater than 0, then what do I get? I'm going to get this case where I'm going to have two intercepts. Okay? Because it's going to be plus or minus whatever b is divided by 2. Yeah? Okay. So then I know, right away by looking at the coefficients here and doing b squared minus 4ac, I know whether I have two intercepts. Okay. What happens if that equals 0? Okay. Let's suppose that we have, 16 minus 16. All right. Does that make, if I have here, instead of 3, I have 4, then it's going to be 4 times 4. That would be minus 16. So then it would be 0. What is the square root of 0?
0.
0. Okay. And so then I'm going to have 4 divided by 2, 2. 1 root. Okay. All right. So if this part, the minus b squared minus 4ac equals 0, then I'm going to have just one intercept. Okay? One intercept. What happens when I have that this part, what is underneath the square root, ends up being negative?
Is there still two intercepts?
Well, yes and no. Okay. What happens, remember that I mentioned that when you have the square root of a negative number, okay, so let's say, for example, minus 16, okay, that turns into an imaginary number. All right. So this we can say this is equal to the square root of minus 1 times 16. Okay, so this we can say is the square root of minus 1 times 4. And the square root of minus 1, we define it as being an imaginary number. Okay, so we have I4. Okay, so it would be plus or minus, because this is again, the 4 is going to be plus or minus I4, so an imaginary root. When you have an imaginary root, the parabola is going to not cross the x-axis, okay? It's going to be either up or down, but it's not going to cross the x-axis. So the roots are here in an imaginary plane, all right? So, okay, so in this case, when we have that the discriminant is less than 0, we say there's no intercepts, no real intercepts. There's imaginary intercepts, but there's no real intercepts. The name imaginary doesn't mean that, oh, I'm imagining something. It's a real number, it's an actual thing, but it's not what we classify as a real number. Okay, so that is why we call it imaginary. Okay, we could have called them a Vincent number, So, all right. So in this case, then we have the number of intercepts. Okay, the number of intercepts is going to be 2, because we have that this part, okay, is greater than 0. So we have 2. And then this is also another critical thing to look, is the axis of symmetry is given by minus b over 2. That part of the quadratic. Okay. So if I have minus b over 2, we are going to see, okay, so let's go over here. In our equation here, minus b is going to be 4 divided by 2 equals 2, and which is right in the middle between my roots. Yeah? Okay. And so here I see, oh, the axis of symmetry then is going to be 2, meaning that is going to be over here. Okay. So it's going to be 2. We have the roots are going to be 1 and 3 is going upwards. So we have it right there. Okay. Can you see how you can graph the equation really fast by analyzing just the coefficients and looking at the different coefficients of what we have? Okay, let's take a look at this other. Let's do one more, okay, and see if this cements. Then let's go. Okay, so let's go for y equals minus x squared plus 4x minus 3. Okay, so now here again, the questions are, is it going up or down? The number of intercepts, okay, and then the axis of symmetry. Mm-hmm. Okay. Mm-hmm. So let's see, Samuel, tell me what you see and what you find here. Is it smiley or frowny? Samuel, drop off. Okay, who's valiant here enough? Okay. Mm. Mason? Mm-hmm.
When Samuel unmuted, the meeting kicked him out.
Oh, that is weird.
He's
Yeah.
working on logging back in.
Okay. Okay. No problem. Mm-hmm. So. Mhm. We have also another case here. We can do y equals. Let's do 2x squared minus 8x plus 8. Okay. So there's another one if you want. Mhm. To keep going. Okay. Let's see. SP, Mason, go ahead. Mm-hmm.
Samuel's in the waiting room right now.
That is weird. I don't see him.
I don't see him either.
Yeah.
Do you want him to do it again? Get out of the waiting room and log back in?
Yes, I think that he may be in the waiting room of next week's class. Okay. So can he be there with you? Can you call him to be there and share your mic?
Yeah, we can do that.
Yeah. Mm-hmm. Okay. All right. So let's see. Okay, so let's unmute and let's see if we can do this. Mm-hmm.
So we're trying to figure out what are we trying to solve?
We are trying to see if this equation, okay, we are going to see, is it frowny or smiley?
Um, it'd be frowny, right?
Frowny, okay, so we have a equals -1. All right, okay, then how
Mm-hmm.
many intercepts do we have?
2.
So let's see, we have 2. We are going to do b squared, okay, minus 4ac. Yeah, all right, and
Yeah.
so we have b squared is 16, okay, minus 4 times a is -1 times c is -3, okay, all right.
Okay.
So that is going to be 16. Okay, so what we have 3 minuses, so we are going to end up with a negative 12. Okay,
Yep.
yeah. So the same thing as we had before. All right. So this is going to be 2, so that is going to be 4. Okay, so it's greater. So we have 2 roots. Okay, 2 intercepts. Yeah.
Okay. Yes.
Okay. And where is the axis of symmetry? Mm-hmm.
Um, I have no idea.
Okay, remember the axis of symmetry is b minus b over 2. Okay,
So it'd be 16 minus 16 over 2.
not b square is just b. Okay, b. This
Okay,
is
so
b.
4.
Uh-huh.
So 4 minus 4 over 2.
It would be -4 over 2. Okay,
Okay.
Wouldn't it be
-4
negative
over
2
2.
because
So -2. Okay, the axis of symmetry is -2.
I mean, wouldn't it be
Okay.
over -2 because the a is -1?
Oh, that's right. So it's 2a. Okay, so that would be, yeah, so that would be 2. Okay. So that would be there. Okay, so minus b over 2a. So we have that is 2. All right. And so we have that this is similar to what we have before. We have the axis of symmetry at 2. The roots are going to be 1 and 3, but now it's going to be frowny. Okay, like that. Mm-hmm. Okay, let's do this last one here. Okay, so we have y equals 2x squared minus 8x plus 8. Okay, and so again, we want to see the up or down number of intercepts, and then axis. Mm-hmm. Okay, and then let's draft that and see. what we end up. SP, what do you think? Let's work on this one. Yeah, you can do it. You can do it.
I, you are. What's the first thing that you want me to do?
Is it up or down?
Up,
Okay, why?
because it's positive.
Okay, so A is greater than 0. Okay, so A equals 2. So up. Okay, yeah. All right. How many intercepts do we have? Let's see the discriminant. So B squared minus 4AC.
2.
Okay, so let's see. B squared. So we have minus 8. Okay, minus 8 squared. And then minus 4 times 2 times 8. Yeah?
I guess. I don't know. I don't really understand this.
Okay. So what we are basically saying is in that these are our coefficients. So this is A, this is B, and this is C. Okay. All right.
Yeah.
And the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac divided 2a. Okay. And so in order to look at the different parts here of the parabola, we have that whatever is here underneath the square root is called the discriminant. Okay. And that is going to tell us the roots, whether we have one root, two roots, or 0 roots. Okay. Whether they are
I see. I see.
greater
Okay.
than 0, equal to 0, or less than 0. Yeah,
Yeah.
that is the whole thing.
Okay.
And then this, okay, minus b divided 2a is going to give us the axis of symmetry, where the parabola is going to be, the vertex of the parabola is going to be. Okay. Yeah.
Yeah.
Okay, so now we have b squared is minus 8 to the square. Okay. And then we have 4ac is minus 4 times 2 times 8, because those A, B, and C. Yeah.
Yeah.
Okay. So what do we have? We have minus 8 squared is what?
64.
64. Okay. And then we have 4 times 2
8.
and 8 times 8.
64.
64.
So
And
it's
so we
equal
have
to
64
0.
minus 64, what?
0.
0. So that is going to equal 0. So how many intercepts do I have?
1.
One intercept. Okay. So the parabola is going to just cross here, is going to touch the x-axis. The vertex is going to be right there. Okay. Now, where is it going to be the axis of symmetry? So it's minus b divided 2a. Okay.
So 8 divided by 2 times 2. So 4 and then 4. And so it's equal to 2.
To 2. Okay. So the parabola is going to be right here.
Yeah.
Is upwards, okay, and it's going to be this way.
Yeah. It's starting to make sense now. I put it into GeoGebra, and so now I'm starting to understand the math for it.
That's right, yes. it's useful to also put it into GeoGebra and manipulate things, change the numbers, see the different things and see how the parabola behaves. Okay. So that is very, very good. Okay. So if we go there to GeoGebra and put that, okay, so we have y equals, all right, so we have 2x squared minus 8x plus 8, okay, and there we have that, and we see the intercept there is at 8, that is the constant term, okay, is going to be there on 0, 2 at the vertex, okay. So we can see a lot of different things and how it's going to go. See how interesting. If I just change that, okay, now it's going to go the other way, and now it's going to still intercept. Can you see the constant term? This 8 is the y-intercept. That didn't change, that point, okay? Now the axis changed from 2 to minus 2, just because I changed the sign.
Okay.
Makes sense, because if now I have a minus, then it would be minus 2 in there. Okay. So really, really cool way of looking at things. Okay. And of course, that now because we do have that minus, then it's not going to be 64 minus 64 is going to actually give us two real roots on that. So fascinating topic, really, really cool. Okay. Keep working at it and playing with these equations. Okay. I don't know that I did a very good job at explaining the vertex, the completing the square, Vincent. Okay. How did you think that I did on that one? I think that I'm like, no, not too good, really. There. Okay. So I'll try to give it another try, maybe see if I can make a little video on that. Okay. So yeah. All right. Yeah, sometimes, the teacher is a little off, okay? It's like sleep deprivation, okay? So too many things going on. It's like, all right. Any other questions or comments here? Okay. So let's stop the recording here.